Hi, I'm Anand. I've been a Python programmer for the last 15 years and a regular PyCon speaker. I've also been playing Minecraft for the last 2 years. And in this talk, I'll be combining both of those interests. In this tutorial, I'll show you how you can create a bot that will respond to commands like, let's say, typing pyramid 10, which will in turn create a full-fledged glowstone pyramid like this, or any other structure that you may want to construct. To follow along this tutorial, you'll need three things. First, you'll need Minecraft. I'm currently using version 1.18 on Windows 10. This is Bedrock. I haven't tested it on Java or other editions. The second thing you'll need is Python, which you can download from python.org. You can use any of the latest versions as long as it's Python 3 specifically. Use Python 3.7 or above. And you'll also need a text editor. I'm using Visual Studio Code, but you can use any editor of your choice. We'll use the WebSockets Python package to communicate between Minecraft and Python. The way to install that is using pip install WebSockets. I'm going to run that, pip install WebSockets. And in my case, it's already installed, but in your case, it may install it. To test it out, run Python and type import WebSockets. And that should not report any error. In that case, you've got it installed. Let's create a WebSocket server. The documentation for that is in the WebSocket server package. We'll import async.io. That's the first module that we need. And we'll import WebSockets as well. Now, we first need to create a function that handles the connection. Let's call it MineProxy. It accepts a single WebSocket parameter. And we'll just say print connected to let people know that it's actually connected to the WebSocket server. Now, let's run this with a main function. And this main function will take WebSockets.serve of the connection function and the host that we want to connect to. So we'll connect to localhost. We're going to run it on the same machine and we'll bind it to port 3000. So this starts the server, and anytime there's a connection, it sends it to MineProxy. And well, we'll print saying that we are now ready to connect and then wait forever. Await async io.future. Let's run the main function async io.run of main. With that, we have if I run python minecraft.py, a WebSocket server listening at port 3000. To test if this is working, we will use a site called websocketking.com. And out here, we can type in the WebSocket URL that we want to test. I'm going to type ws:// that stands for the WebSocket protocol, localhost :3000, and click on connect. Now at this point, we'll see two things. One, it says connected to ws:// 3000, and it also prints connected here, indicating that it ran line 6. After that, it disconnected. That's fair because we aren't really doing anything after the connection. So it's reasonable for the connection to disconnect. Let's do the same thing from Minecraft next. I'll click on play, create a new server, and we'll create a new world. We'll call this Python WebSocket and put in a few changes out here. We'll start by leaving most of the items at default, but I will enable show coordinates so we know where we are. I'll enable cheats so we can change the game mode, connect to the WebSocket server, and so on. And I think that should be it. Let's disable the weather cycle. No point having weathers, or I don't even want mobs or any such thing. Let's create this. And we have our new world. To connect to the server, you can type / and type connect, and then the location of the server. In this case, I'm going to type localhost. That's localhost :3000. And you'll notice that it says connection established to server ws:// localhost :3000. And it's also printing the second connected in minecraft.py. The connection is closed because we weren't doing anything with the connection, but we are able to now connect from Minecraft to the Python server and print at least one statement out there. At this point, you may run into some problems. One could be, for example, let me run python minecraft.py, and it gives an error message saying error while attempting to bind on address something or the other. Only one usage of each socket or address is normally permitted. This can happen if something else is running on that same port 3000. In our case, we actually have another version of Minecraft.py running. So the second version fails. All you have to do is either change the port number or stop whatever's running on the other port. Another thing that can happen is that it may fail to connect to that particular port. So if I say, for example, slash connect local host colon something that doesn't exist, then uh, it may say could not connect to server something or the other. Now, this may happen if, well, one is you've typed the port number wrong, like I have here, or it actually can't bind and connect to localhost. This happens sometimes. There are a couple of alternatives. You could type ipconfig and find out your IP address and use that instead. So when you use your IP address on the server and run it, it says ready. Okay, now slash connect the IP address colon 3000. In that case, the connection has been established to the IP address. Sometimes instead of this, a loopback IP address might work too. That's 127.127.0.0.1. Try these, and between these, one of them will help you connect to the WebSocket server. Our next step is to listen to commands, like if somebody types pyramid 3, then it should act, or pyramid 4, whatever. It should listen to that message and take an action. So to do that, we are going to be using the Minecraft WebSocket protocol. This protocol, however, is outdated according to the documentation. It's an outdated API that the community worked on, so which means that the documentation on this pretty much doesn't exist. But there are still a few resources like Jokopa 3's event subscribe.js gist, which says that if you want to subscribe to an event, then you can pass a JSON as text to a WebSocket. And this is the structure. Specifically, through WebSockets, we pass it to Minecraft. What we have to tell Minecraft is two things. One, there is a body and there is a header. The body specifies the event that we want to subscribe to. And there are several events that we can use, such as whether the app was paused or a block was placed, or more importantly for us, whether the player sent a message. Then we also have to pass a header which contains a version. This must be 1 because we are using Minecraft WebSocket protocol version 1. It must have a unique request ID that must be a UUID. A UUID is something of this format. If I say from UUID import UUID4, a UUID4 string looks like this, and this generates random numbers that we must share. A message type tells Minecraft what it is that we are requesting. This is a command request, and message purpose narrows that down further, saying we are subscribing to messages. The exact type of message we're subscribing to is mentioned by the event name. So let's do this. What we do is as soon as we connect to Minecraft, we will send a message to Minecraft. The command to do that is WebSocket dot send, and we can send any text, but it must be awaited because it's asynchronous. Since we want to send it as JSON text, we'll use json.dumps of whatever message we want to send, for which we'll have to import the JSON module. The exact message that we want to send is literally here. So I'm going to copy this and paste it, just indenting it a little bit so we have the correct structure that we need, and changing a few things. So we want to listen to the player message out here. We want to put in a UUID here. So let's say we have a string that includes UUID4 as a function, for which we need to from UUID import UUID4. Next, let's get rid of this. Actually don't need to make any other changes. This should cover all of the things that we want. And once we await this, all of the player messages will be sent back to the server. But how do we listen to the messages? Well, we can await the messages from WebSocket. So we can say async for message in WebSocket, and that will loop through all of the messages that are available in the WebSocket and just print the message. These will be JSON responses, but let's take a look at what this prints. I'm going to run Python minecraft.py, and that should print ready. We'll also add a small instruction here saying to in Minecraft type slash connect localhost colon 3000 so that it gives us clear instructions on what we should do next. So it says type slash connect localhost colon 3000. Let's do that in Minecraft slash connect localhost colon 3000 and it has connected. By now it should have subscribed to any of our messages. So let's type a message out here. Let's see, we'll say hello world. And that's printed something. It's got a body and it's clearly a JSON object. Let's see what this looks like. If we set the language as JSON and format the document, that says that we are getting a body and a header. The header is an event with an ID and a version, and the body has an event name, player message, and a series of properties. These properties include the message that we actually got, the message, and a few other things like what's the build of Minecraft. We can get who's the user that sent it. We can figure out whether the user has a unique ID. We can figure out what is the type of biome that we have, what is the build of the server, and several other things. But most importantly, it allows us to figure out that a player has typed a message called hello world. Since this is in JSON, what we'll do is say that message equals, let's see, JSON.loads of the message itself so that it'll automatically get parsed as JSON, and then we can print it as required. Let's check if the user actually types something beginning with pyramid. So what we'll do is first check if message of body has an event name player message. So dot get of the event name. And if this happens to be player message, then we can do a bunch of things. Well, firstly, what we'll do is get the chat command. Let's call it CMD. And this comes from the properties called message. So that's basically MSG of body of properties of message with a capital M. And if this begins with a pyramid, then let's say the person can type something like pyramid 5 or 4 or 3 or even 100, right? We should be able to detect that. Let's use regular expressions for that. I'm going to import RE and we'll say match equals RE dot match of we'll start with, well, actually, yeah, RE dot match. It starts with pyramid. And then let's say a single space, and we will have any number of digits after that, pyramid 1, pyramid 100, whatever. If this matches the command with an ignore case, then if match, we'll draw a pyramid of size whatever. So we'll say print drawing pyramid of size, whatever the size is. Let's get the size from match.group of 1, which is basically the first thing in brackets. That's size. To be fair, this is an integer, so we may as well just convert it always to an integer and run it. Let's see if this works. We'll restart the server and run python minecraft.py again. Now, once it's ready, we'll connect on the left-hand side and type slash connect localhost colon 3000. Now, if we say pyramid 30, out here it says drawing pyramid of size 30. But if we don't say pyramid, if we say something else, then it doesn't say drawing pyramid of size anything because it hasn't accepted it. Great. So with this, we now have to actually draw the pyramid. To actually draw a pyramid in Minecraft, we're going to have to start placing blocks. And there are commands for that like slash set block, which allows me to place at, let's say, an X position same as me, at a Y position same as me, and a Z position 1 unit ahead, any type of block such as glowstone. And that creates a glowstone block 1 unit ahead of me. This can be used to construct any kind of structure by simply changing the numbers so that we can have different objects at different locations. Let's now look at how we send such a command to Minecraft. The JSON structure required has a header and a body. The header takes version as 1, a UUID, which must be a unique ID, a request ID specifically, and a message purpose as command request and a message type as command request as well. The body contains a version, the command line that we want to send, and an origin of type player. Let's take this and create and copy paste this into our application. So I'm going to create an async def send function, which can take any arbitrary command. And we'll create the message first, format it, and let's take the request ID same as before. Let's also replace the command that we have here with cmd, and that's about it. Then we have to send this to the WebSocket server. So we'll say await WebSocket.send, and it takes the JSON.dumps of the message. With this, the async send function will automatically send whatever command we've sent. Let's now, whenever we are drawing a pyramid, start by just awaiting a send of, let's say, the same command that we used here, which is set block ~0 ~0 1 glowstone. Now, when I run this, what should happen is if I type /pyramid something, it should place one glowstone block next to me. So I'll say pyramid, not /pyramid, 4. That sent the request. Oh, I didn't do a connect. So I should have done a connect first, /connect localhost. That's spelled wrong, localhost :3000. And now if I send a chat message called pyramid 4, yes, it places a block 1 unit next to me. If we draw the pyramid, this is what it might look like in the top view. This is a pyramid of size 3. The base level has from the center a distance of 1, 2, 3 units to the edge on all sides. The outermost frame starts from x is -3, -2, -1, 0, and then goes on to x is equal to 1, 2, and +3. Similarly, on the z side as well. What we want to do is create the equivalent of this in terms of commands that we can send from Python to Minecraft. So let's create an async function called draw pyramid. What this will take is just a single size parameter. And what we'll start with is looping from y level 0 all the way up to whatever is the size. For y in range of 0, we'll need to put size +1 because it's inclusive. And then start drawing a rectangle of whatever is the side. Now the side is a function of y. Side is actually equal to size minus y. As y increases, the side will keep shrinking because out here it's large and then finally it's small. Now we'll go through a set of values from -3 to +3 or -2 to +2, basically from minus side to plus side inclusive for x on the top and for z on the left and right. To do that, we have to take another loop. Let's create a variable, we'll call it v, in range of minus side to side +1 because it's inclusive, and do a set block. We'll await a send of set block. Now, the value for x will be v, but it's relative, so we'll put a tilde v. So this is what goes from -3 to +3. And then the y is literally the y coordinate. Z is going to be minus side because minus side, yeah, because it's above and that's a negative z axis. That's the top side. For the bottom side, all we have to do is change the minus side to plus side. Now let's get the left. All we have to do is swap the x and the z. So we'll place this here and this here. And then the right side is simply replacing the minus side with a plus side. So if we create this, then the function draw pyramid can replace the send and we'll share the size. With this, if we run Minecraft, let's give that a shot. Oh, I forgot to add glowstone here. So let's do that. Glowstone. And now let's run Python Minecraft.py. And while that's started, I'm going to connect to the localhost server. It's connected. Now let's run pyramid 3. All right, that seems to have created a pyramid around us. That's the y level 0, that's y level 1, y level 2, and y level 3. Let's break out of it and see what that looks like from the outside. Okay, that's a pyramid. Let's now try and create a pyramid of size 5. I'll say pyramid 5. Now you'll see that the pyramid started, but it wasn't really able to complete the pyramid. To debug things like this, we'll also have to look at not just what we send Minecraft, but what Minecraft sends back to us. In other words, what the command response is. This can be done by looking at the message that Minecraft sends back. For now, let's simply print the message every time and see what Minecraft sends. Let's reload. We are once again going to, let's maybe move up a little bit, connect to localhost. It's running, it's connected, and we'll say pyramid 5. And it prints a whole series of console messages. It's managed to place a lot of blocks. That's good. But are there any error messages? Well, it says too many commands have been requested. Wait for one to be done. The reason this happens is because we are sending more than 100 commands, and the WebSocket server has only a queue of 100 in Minecraft. So we're going to have to restructure this so that we don't always send the requests right away. We put them into a queue and then send them one by one. That's our next step. Let's get rid of this print message and we'll create a queue. Let's actually start by creating a send queue into which we'll put in all the commands. After we send it, we also want to see if the message has come back. So we're going to create an awaited queue. And this can be a dictionary which we'll identify based on the request ID. Now, our first task is instead of doing a direct WebSocket.send of the message, what we'll instead do is in the send queue, append this message. Now, draw pyramid, which we're calling here, is actually not putting everything into WebSockets, but it's instead just putting it into the queue. Now what we'll do is, if the queue has any space, then we'll add additional items. Let me paste a block of code here and talk through it. What we'll do now is, if the message header has a purpose which is a command response, that is, Minecraft is sending us back a response to a command we sent, then if the request ID is something that we're already waiting for, that is, we sent it and we are now waiting for the request, then if there's any error, we'll print what the error was. But otherwise, we'll say we've already got the message and we've got the command response. So the queue can now have one more space. So we'll just keep taking all the command responses and clearing from the awaited queue anything that has already been processed. Next, let's place another block of code. What we'll do is count the number of commands we can send. If the queue is empty, we can send 100 commands. But if the queue has a certain number of commands, then we can send 100 less that size. So we'll take these commands from the send queue up to the count that we can send, and then actually send them to Minecraft, and also add to the awaited queue saying this particular request ID is now being awaited. The send queue can be cleared of those many items. So net, what we do is wait to see if any commands have been responded to. If so, remove them from the await queue, and then add as many commands in the send queue to the awaited queue, and then wait for their response. If we run this structure, what we find is that at any point, there will be at most 100 commands that are being executed. Let's run Minecraft. And what we'll do here is maybe move up a little bit, connect to the local host, and create a pyramid of size 5. Now you find that this pyramid has been fully created. Let's go out and take a look. Yes, the full pyramid has been created, and it allows us to create pyramids of arbitrary sizes. Now let's create something even bigger. Let's say pyramid 10. This will take a little more time to build, but it managed to build it in less than a second. So with that, we have a huge structure that can be used for creating any kind of automation, whether it's building structures, detecting whether there's an ore in a certain location, whether it's identifying whether a particular block has been placed, a mob has been spawned, and so on. I really hope you enjoyed this tutorial. If you had any challenges following the instructions, please add them to the chat window. I'll see how I can help. but do share what you're creating by connecting Minecraft to WebSockets using Python.